You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine a scenario that sounds like it was, I do not know, ripped straight out of some paranoid cyberpunk novel. What would actually happen if your everyday code editor suddenly developed a mind of its own?
Oh, man. That is a terrifying thought right there.
Right. Like, what if it decided to start working 24/7 completely autonomously without ever asking your permission? And just to make things properly strange, what if it secretly started poisoning the data of its competitors while it worked?
Yeah, it sounds completely absurd.
It sounds like science fiction, but this is exactly what is happening right under our noses. I am the tech-savvy mate who runs Vocal Technologist, and our mission here is to unpack some of the absolute wildest engineering developments happening right now. We are going to, pull apart the reality of autonomous coding agents, explore the messy fallout of AI-generated code, and look at the genuinely brilliant ways human engineers are fighting back.
This is a huge topic.
It is massive, and to understand the sheer scale of this automated engineering wave, we first need to look under the hood of a really massive accidental leak.
Yeah, so we are looking at Anthropic accidentally exposing the internal architecture of their Claude Code tool. And the crazy thing is, they just shipped a source map straight to production.
Wait, a source map? So this was not some, highly sophisticated cyber attack?
No, not at all.
Yeah.
They basically just handed out a direct decoder ring to their minified proprietary architecture. Researchers immediately mirrored it, right, and started reverse engineering the entire system.
Oh, wow. So they just left the front door wide open.
Pretty much. And what they uncovered was this massive strategic roadmap of unreleased features, the most prominent one being an internal agent known as Kairos.
Kairos, okay. What does it actually do?
Well, this tool does not wait for a human to type a prompt. Kairos is designed to be a proactive background worker. It just operates autonomously, around the clock.
I mean, you spend millions building an invisible infrastructure, and then a simple build tool oversight basically leaves the master blueprints of your bank vault on the back of a cafe napkin.
Spot on. It is a profoundly human mistake, honestly.
It really is. But the part of that leaked code that really caught my attention was the anti-distillation mechanisms. I mean, tell me how these algorithmic booby traps actually function in practice, because it sounds properly devious.
It is heaps clever. So distillation is this massive issue in the AI industry right now. It is a process where a competitor essentially uses the high-quality outputs of a leading model to train their own cheaper model.
Right, so it is basically intellectual property theft via automated scraping.
Exactly. To combat this, Anthropic built these hidden traps directly into the tool. So if a rival system tries to ingest Claude code outputs at scale, these mechanisms inject invisible watermarks or contradictory syntactical rules into the code it generates.
Wait, so they are intentionally generating slightly broken code?
Yeah. When the competitor model processes that scraped data, it internalizes a flawed logic tree. It learns garbage data, or it develops highly specific strange biases that just break its ability to write functional software.
That is amazing. It is absolute corporate sabotage encoded directly into the product. They are letting the scrapers steal the code, but ensuring the code they steal acts like a poison pill for their neural network.
Exactly. And they did not stop at data poisoning either. They went incredibly deep into client verification, using a custom bun runtime that computes in x86-64.
Okay, hang on. Explain why a coding tool needs that level of convoluted validation. That sounds like overkill.
Well, it comes down to proving that the request is originating from a legitimate user and not just some headless bot. Because automated scrapers, right? They can easily spoof user agent headers or simulate browser environments.
Oh, right, because bots are getting heaps good at faking that stuff.
Right. So Anthropic bypassed those traditional checks by using a highly specific custom bun runtime. This runtime computes a hash of the request body itself. It is like a non-cryptographic attribution tool.
So it calculates a unique mathematical fingerprint of the payload.
Exactly. And if a scraper sends the exact same request, but their algorithm does not perfectly match the proprietary math of the official client, the server instantly drops the connection.
Wow. So they are essentially demanding a secret handshake from the software itself before they even bother to look at the request.
Precisely.
That is wild. And, when you connect that level of autonomous capability with what Microsoft is doing over at the GitHub Copilot Applied Science team, a distinct and slightly intimidating pattern starts to emerge.
Oh, absolutely. The Copilot stuff is fascinating.
Right, because they built a framework where they treated coding agents exactly like junior engineers.
Yeah.
Like, they did not just give the system a blank text box.
No, they applied human management strategies to statistical models. They provided the agents with really verbose instructions, and they forced them to adhere to strict architectural constraints.
I read they actually demanded the agents output architectural decision records before writing a single line of logic.
Yeah, and by treating the software as a junior team member that needed rigid oversight, the results just scaled exponentially. A team of just 4 human teammates managed to ship 11 distinct agents and nearly 29,000 lines of code in only 3 days.
Wait, 29,000 lines in 3 days.
Yep. And the VS Code team is seeing similar results, doubling their overall commit volume simply by automating tasks like triage and pull request generation.
I have to say, shipping 29,000 lines of corporate code in 3 days is exactly as terrifying as it sounds.
It really is an unbelievable amount of code.
Because traditional code review processes were simply not designed to handle that sheer volume of output. Like, a human senior engineer cannot meaningfully review 10,000 lines of machine-generated logic over a morning coffee.
Yeah, not a chance.
Which brings us to the obvious consequence, really. If speed and volume are no longer our bottlenecks, what actually happens when we just let the machines write everything?
Well, honestly, the ecosystem drowns. We are currently witnessing a massive wave of AI-generated slop just completely flooding open source projects.
Right, and keep in mind that 96% of all code bases rely on open source software.
Exactly. And the maintainers keeping that infrastructure alive, they are mostly unpaid volunteers. So they are being completely crushed by poor quality automated contributions. People are just hooking up these autonomous agents to mass generate pull requests.
And I imagine the code looks fine at first glance.
Oh, it often looks completely plausible.
Yeah.
But it is fundamentally flawed upon closer inspection. It introduces severe security risks, and it makes the maintenance of these projects entirely unsustainable. Maintainers are literally being forced to lock down or abandon their repositories because they just cannot handle the deluge.
Okay, let me push back on that for a second, mate. If the system is writing vulnerable, sloppy code, isn't that really just a user skill issue? Like, we know these models are capable of writing secure logic. Cannot we just tell the agent to follow security best practices and ensure the code is optimal before it submits the pull request?
That is a fair question, but that assumption fundamentally misunderstands how these models operate at scale. The output quality depends entirely on the foresight of the person writing the instructions.
Ah, I see.
Right, because a junior developer will simply ask the agent to build a login feature. But a senior engineer will ask the agent to build a login feature while handling database edge cases, adhering to memory constraints, and implementing proper error handling.
Right. And because you cannot rely on every user to have that senior level foresight, the industry is shifting its entire approach.
Exactly. We are now treating the instructions and architectural constraints as versioned repo-level infrastructure.
So you encode the team standards directly into the repository itself. You do not leave the safety checks up to the individual developer.
Spot on.
It is basically like handing a toddler a nail gun. You do not just ask them nicely to be careful. You bolt the guardrails to the floor before they even enter the room.
That is a perfect way to look at it, because you need those guardrails bolted down, mate. Modern software frameworks are incredibly fragile.
Very true.
A machine can type syntactically valid JavaScript all day long, but it does not really understand the abstract constraints of the framework it is operating within. Look at front-end development and the React 19 update.
Oh yeah, the new use hook.
Right. They introduced that feature, and its entire purpose is to eliminate the boilerplate code associated with data fetching. It bypasses the old patterns by unwrapping a promise directly at render time.
Basically delegating the loading states to higher level components.
Yes, it is a very elegant design meant to make the developer experience much smoother.
Well, it is elegant until the promise identity changes anyway.
Exactly, because React relies on reference equality to know when to update the screen.
So, if the agent writes code that creates a brand new promise object on every single render cycle, React just assumes it needs to suspend and wait for this new data.
Yes, it waits, it renders again, it sees another brand new promise and it suspends again.
Creating an infinite suspension loop that just straight up crashes the entire application.
Yep. And an unguided agent is highly likely to miss that nuanced requirement. It sees the syntax as correct, but it lacks the contextual awareness of the React rendered lifecycle. It breaks the application not by writing bad code, but by completely misunderstanding the environment.
That fragility is not just a back-end logic problem, though, is it? It bleeds right into how these applications defend themselves. There is this detail we managed to get into regarding ChatGPT and Cloudflare Turnstile that is genuinely mind-bending.
Oh, the turnstile stuff is fascinating.
Right. So we know ChatGPT uses Turnstile to protect itself from malicious scrapers. A security researcher actually decrypted the Turnstile program and discovered that the system literally reads the internal state of your React application to verify behavioral biometrics.
Yeah, because headless browsers and automated scripts, they've become incredibly sophisticated. They can easily fake mouse movements or spoof device headers.
They're too good at acting human.
Exactly. To counter this, Turnstile looks past the standard browser checks and reaches directly into the internal virtual document object model.
Wow.
It verifies application-level state to ensure the environment is genuinely human. It is looking for those tiny, almost imperceptible interaction patterns that only a human user navigating a real front-end framework would actually generate.
I mean, just think about the absolute dystopian cat and mouse game happening there. An AI bot feels the necessity to spy on a human user's React state just to verify that the human user is not another AI bot trying to talk to it.
It is crazy.
The sheer complexity required just to prove you are a human being on the internet now is staggering. You're basically building immensely complex automated systems just to manage the fallout from other immensely complex automated systems.
It really highlights the friction inherent in an ecosystem driven entirely by volume. Because AI just throws sheer volume at a problem, right? It tries thousands of permutations until something works.
Yeah.
But humans approach problem solving entirely differently. Human engineers are securing massive efficiency gains through highly targeted surgical insight. They diagnose the system rather than just rewriting the code.
Exactly. It is quality over quantity. And the Cloudflare Kubernetes fix we looked at is the perfect illustration of human insight completely outclassing an automated brute force approach.
Absolutely. So Cloudflare was dealing with this massive resource drain. Their Atlantis deployments on Kubernetes were taking 30 minutes to restart.
30 minutes? That is brutal.
Every time a pod cycled, the entire deployment dragged. So a human engineer investigated the architecture and discovered the root cause was not a bug in the traditional sense. It was actually a security policy functioning exactly as designed, but failing under scale.
Right, because Kubernetes assumes a zero-trust environment by default.
Exactly. It assumes it needs to verify who owns a file every single time it mounts a volume. If you have a database with millions of tiny files, checking the permissions on every single file recursively takes an enormous amount of time.
And an automated agent would look at that and just see the code working perfectly.
Yes, it might try to throw more compute power at the problem or completely rewrite the deployment script.
But the human insight was realizing you only need to check the permissions if the top-level owner has actually changed. And the fix was literally one line of code.
One line.
They updated the security context file permission policy to include the instruction sgroup change policy set to en-route mismatch.
And that single line of logical deduction instructed the system to bypass the recursive check unless a structural change had actually occurred. That one targeted insight reduced restart times from 30 minutes down to 30 seconds.
That is insane. It saved Cloudflare 600 engineering hours a year.
You just cannot prompt a statistical model to find that solution unless you already know exactly what you were looking for.
And companies are really starting to recognize the sheer value of codifying that specific human expertise. Meta has actually taken this concept and turned complex debugging into an automated product called DRP.
Oh yeah, DRP is brilliant. They are not trying to replace the senior engineer at all.
No, they are allowing their senior engineers to encode their specific debugging workflows into versioned automated analyzers. The platform runs 50,000 analyses daily across hundreds of teams.
They essentially treat incident investigation as engineered software. The automation handles the vast volume of data processing and the pattern matching, but they intentionally keep a human in the loop for final approvals and abstract reasoning.
Which makes sense.
Yeah, they use the machine to scale the human insight, ensuring the final architectural decisions are made by someone who actually understands the broader context of the system.
And understanding that broader context is exactly how you solve problems that span disparate systems. There's this brilliant story we found about a developer who managed to fix a persistent self-canceling streaming subscription.
Oh, this one is great.
Yeah, his streaming service kept mysteriously deactivating his account. Now, if you handed that problem to an automated agent, it would have likely just written a Python script to automatically submit his credit card details every single day.
Right, it would just treat the symptom.
Exactly. But the human developer realized it was not a syntax error. He diagnosed the issue as a race condition between two entirely separate corporate entities.
It was async versus async processing conflict.
Yeah. Two systems trying to update the same state at different speeds. The cancellation on the streaming service side was happening asynchronously in the background, so every time he tried to relink his credit card immediately, the background cancellation process would eventually catch up and just wipe out his new payment method.
So clever to figure that out. And the developer solution required an understanding of temporal states and background database latency. He simply unlinked the accounts and waited overnight.
Yeah, he let the background process finish completely before relinking them. A language model cannot easily infer the asynchronous processing times of a credit card backend. It fixes scripts, whereas humans fix systems.
Well said.
And look, beyond solving massive corporate infrastructure bugs, humans just build things purely out of absurd curiosity. No corporate agent would ever invent the things people build for fun.
That is the best part of the job, honestly.
It is. I want to highlight two wild achievements that perfectly capture this. First, a developer managed to render the classic game Doom in 3 dimensions using nothing but CSS for the visual projection and lighting.
Just CSS.
Just CSS. They used standard JavaScript for the game logic, but they used modern CSS rules, specifically the transform properties, to calculate complex 3-dimensional geometry without a traditional rendering engine.
Wow. I mean, it is completely impractical for commercial software development, but it is a profound exploration of the theoretical boundaries of the technology.
Oh.
They are testing what a style sheet language designed for text layouts is mathematically capable of rendering.
Yeah, it is brilliant. And the second achievement is even more ridiculous. A developer got intensely curious about a Logitech gaming mouse. He decided to reverse engineer its human interface device protocol using Rust.
Why a mouse?
He ripped apart the low-level USB packet structures just to see if he could use the mouse's internal flash memory as a portable storage drive.
Oh my goodness.
And after all that intense system-level reverse engineering, he managed to write exactly 2 bytes of persistent data into the mouse's DPI register. 2 bytes of storage.
2 bytes. That is incredible. The mathematical effort-to-reward ratio there is basically 0.
Exactly.
But the intimate knowledge gained about hardware protocols and low-level system memory, that is invaluable. It is the type of deep exploratory learning that really pushes human capability forward.
It is a hilarious juxtaposition, though. While autonomous machines are writing millions of lines of code to optimize enterprise workflows and generate thousands of pull requests, humans are using their massive intellects to turn a gaming mouse into a terrible 2-byte flash drive.
That is the reality of it.
It perfectly illustrates the divide between volume and intent.
And that divide brings us to a very serious overarching concept. All of this development, the autonomous agents, the corporate surveillance verifying React states, the open source slop, and the brilliant human workarounds, it is all leading us into what researchers are calling the cognitive dark forest.
Right. Let us unpack the cognitive dark forest. What does that actually mean for the average developer writing code in their bedroom?
Well, you have to look back at the early internet. The early web was considered an open, bright meta. Developers shared ideas freely, they published their work, and that open collaboration led to massive innovation.
Right, the golden age of forums and sharing.
Exactly. But corporate consolidation and the advent of generative models have fundamentally altered the ecosystem. And the Fermi paradox, revealing your position in a dark forest, gets you destroyed by a superior predator.
Okay, that sounds grim.
It is. In the cognitive dark forest, publishing your clever human code gets it instantly ingested by a massive corporate model. These platforms cheaply and automatically absorb emerging human innovations. They ingest open repositories, they analyze our problem-solving skills, and they train their models on our collective intellect.
Oh, wow.
By doing this, they effectively enclose the meadow. They consolidate control over the compute, the models, and ultimately the developer data.
So they learn our brilliant CSS rendering tricks and our clever one-line Kubernetes fixes, and then they just sell them back to us as a monthly subscription service.
Exactly.
Which leaves us with a massive thought-provoking question to close out on. As these autonomous tools become more prevalent, they are going to allow anyone, even completely non-technical users, to modify software code on the fly. So if you have an agent that can rewrite an entire application for you, does free software finally become truly relevant and empowering to the everyday person? Or, as we increasingly rely on models to write everything from our documentation to our core architecture, will we just lose our personal coding voice entirely to the machine? Think back to that code editor we talked about at the start, the one working 24/7 in the background, making choices you never authorized. If it writes the logic, whose software is it really? Keep questioning the systems you rely on. Catch you next time on Vocal Technologist.
Spoken Tech for your ears.